In this video, we are going to discuss composition of functions. And composition of functions, you're given maybe two functions, maybe even three, and you're asked to compose one function on the other. The way these are expressed here, f of g of 3, g of f of 1, f of negative 2, g of negative 3. These are examples of composition of functions. And the rule is you need to evaluate inside first, and then work your way outside. So if I'm asked to compose f of g of 3, I'll evaluate g of 3 first, which means I have to put 3 into g. So f of g of 3 is the same as saying f of 3 squared minus 2, and that is f of 7. I worked my way inside out. I start inside, and now I evaluate f of 7, which would give me ultimately f of g of 3. So f of 7 means I have to put 7 into f. f of 7 is 3 minus 2 times 7. That's 3 minus 14. That's negative 11. And so f of g of 3 equates to negative 11. Composition of functions. You compose one function on another. The output for one becomes the input in another. In other words, the output g of 3, okay, becomes my input in f. G of f of 1. So evaluate g of f of 1. Well, g of f of 1 is the same as saying, let's find g of 1. And why am I saying g of 1? Because if I put 1 into f, I get 3 minus 2, which is 1. So g of f of 1 is the same as evaluating g of 1. G of 1 is 1 squared. Notice again, I wrap that 1 in a pair of parentheses, subtract 2. Well, in this case, it was positive 1, so 1 squared is 1. Take away 2 is negative 1. In other words, g of f of 1 is negative 1. Let's try one more. I want to evaluate f of negative 2. Well, in that case, I'm going to figure out what f of negative 2 is first, and then that output becomes my input, gets put back into f. So f of negative 2 is the same as saying f of 3 minus 2 times negative 2. That's the same as saying f of 3 plus 4, which is f of 7. Now 7 goes into f. f of 7 is 3 minus 14, which we found in a previous example to be negative 11. f of negative 2 is negative 11. Last but not least, g of negative 3. Well, I have to first evaluate g of negative 3. That output becomes my input, my new input into g. So let's do that first. G of negative 3 is the same as saying g of negative 3 squared minus 2, which is the same as saying g of 7, because negative 3 squared is 9, and 9 minus 2 is 7. So now I put 7 back into g. G of 7 is 7 squared minus 2. That's 49 minus 2. That's 47. And so g of negative 3 is 47. Composite functions, we're composing one function on another. Now, let's take it a step further. I want to find a general formula for g of f of x. In other words, what's an equation that I could put such that I could put anything in and it would automatically kick out g of f of x? Well, g of f of x can be expressed as g of 3 minus 2x. G of 3 minus 2x. Now, I have to put 3 minus 2x into g. That's my input that goes into g. And so g of 3 minus 2x is the same as the quantity 3 minus 2x quantity squared minus 2. We talked in class about the shortcut. If you're squaring a binomial, and I want to strongly encourage you to memorize this shortcut. If you're squaring a binomial, a minus b, you square a, so 3 squared is 9. You subtract twice, so 2 times the first times the second, so that's going to be minus 2 times 3 times 2x. And minus 2 times 3 is minus 6, times 2 is minus 12x. And then you add to that the square of the second, so that's going to be plus 4x squared minus 2. Again, I got this piece, I'll remind you, I got this piece by foiling 3 minus 2x times the quantity 3 minus 2x. Foil f first times first gave me 9. The combination of outside and inside gave me my minus 12x. And then last times last, negative 2x times negative 2x gave me plus 4x squared. Now we could clean this up one step further, and I would certainly expect you to. 9 take away 2 is 7. And so I'm going to rewrite this as positive 4x squared minus 12x plus 7. There is a general formula for g of f of x. Now, if you'll recall, we got, for g of f of 1, we got negative 1. So I should be able to take 1 and put it into my general formula here, 1, and I should get negative 1 out. Let's check. If I put 1 in, 4 times 1 squared is 4 times 1, that's 4. Minus 12 times 1 is minus 12, plus 7. Well, 4 plus 7 is 11, and 11 minus 12 is negative 1. Check. The general formula for g of f of x, you could put anything in, and you'll get g of f of that value out, is again this formula here. Let's find a general formula for f of g of x. The general formula for f of g of x would be f of x squared minus 2. And so f of x squared minus 2, again, means that I now have to put x squared minus 2 in to f. That goes in. So f of x squared minus 2 is the same as saying 3 minus 2 times x squared minus 2. Of course, I would expect you to expand and simplify. And so I distribute my negative 2. I get 3 minus 2x squared plus 4, which is negative 2x squared plus 7. There is a simplified version of f of g of x. Again, you should be able to put any x value into this formula and get f of g of x. We could check. We composed f of g of 3, and we got negative 11. So let's put 3 back into this function here, and let's see if we get negative 11 out. Well, is f of g of 3 negative 11? F of g of 3 is the same as saying negative 2 times 3 squared plus 7. That's 3 squared is 9, that's negative 18 plus 7, which is in fact negative 11. So again, that checks out. The general formula for f of g of x is negative 2x squared plus 7. Last but not least, I'm going to challenge you. I'm going to encourage you to pause the video here and try this one on your own. So what's a general formula for g of x? G of x is the same as saying g of x squared minus 2. And so x squared minus 2 gets put in to g of x. So g of x squared minus 2 is the same as saying quantity x squared minus 2 quantity squared minus 2, which is x squared minus 2 times x squared minus 2 minus 2. Again, the shortcut that I'd like you to know is that if you square a binomial, you square the first. X squared squared is x to the fourth. In this case, again, we subtract because of that subtraction symbol. So minus 2 times the first times the second, so that's going to be minus 4x squared. And then I add to that the square of 2, so plus 4. And then, of course, we've got this minus 2 tacked onto the end. I'll clean it up. I get x to the fourth minus 4x squared plus 2. That is the cleaned up version of g of x. And if you want to check, you, of course, could, if you wanted to expand, you would FOIL. First times first, outside times outside, inside times inside, last times last. That would give you this, but it's good to know the shortcut. And so here's our general formula. Again, we might check, hey, g of negative 3. Here's our general formula for g of x, so put negative 3 back into this formula and see if you get 47 out. Well, Negative 3 raised to the 4th is negative 3 times negative 3 times negative 3 times negative 3. That's 81. Okay. Minus 4 times negative 3 squared. That's minus 4 times 9 plus 2. That's 81 minus 36 plus 2. That's 81 minus 34, which does in fact equate to 47. So that checks out. That's all I've got.